Hello, Amy. How are you?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. So today, what do you want to do?
Um, so I had an assignment which was to do with like moments and everything. And I was just wondering if well, I haven't really got it back yet, but I had a couple questions that I had difficulties with. So I was wondering if we could just work through them. And I feel like it covers most of the concepts in the chapter as like moments as a whole. So it'll be
Mhm.
really nice to just tie in everything that we've learned over the couple of like past weeks and just really understand moments because again, this physics, like I told you before, mechanics side, I feel it quite hard to understand because my brain's not wired in this way. So yeah, those would be really helpful if you could help me out with these questions,
Sure, sure,
please.
sure. So why don't you share your assignment which you have submitted? We can discuss it now, right? So you can share your screen.
Um, I know there's so many parts to it. If you can see that there's some that are similar, we can just do one from it and then move on because I'm just trying to get the concepts.
Okay, okay. So let us take this one. The question here is, well, let's read the top. If a numerical value of g is required, take g as 9.8 meters per second square. Give all non-exact answers correct to three significant figures. Very important to understand, unless otherwise specified. Question number one is, in each of the following diagrams, find total clockwise moment, right? Total clockwise moment about P in Newton meters of the system of forces, correct? So we have given a lot of examples. I think we should consider this one with parallel lines and tell me how will you do this particular question where the point of interest is P and we have 9 newtons going through it, 10 newtons above and 7 newtons below, and both are 1 meter away perpendicularly from P. So how will you do 1C?
Um, So to be honest with you, I we were just trying to find the clockwise moment.
Right.
So would we only look at so like both the 10 Newton one and 7 Newtons is in the clockwise motion in
Yeah.
terms of
So
P.
this will give you clockwise, that will also give you clockwise, right? So we'll
Yeah.
add them up,
So
correct?
just add them. Yeah.
Yeah, and 9 will give me 0 because the distance is 0, right? The
Yeah.
shortest distance. And you're right. So it'll be 10 times the distance between the two, which is 1, plus 7 times the distance between the two. And the other one is actually 9 times 0, since the distance is 0. So you can add them up. You get 10 plus 7, which is 17 Newton meter. Is it okay?
Yeah.
And that is clockwise. Perfect. Now I'd like you to do part D. How will you do part D?
Um so with the 10 Newtons, you've got a clockwise motion, but
Correct.
then with the 20 and 15 it's anti-clockwise. So you won't include those, would you?
We'll subtract them. So we'll keep
Oh, so you
positive.
would. Okay.
Yeah, we'll keep positive with 10. So we have 10 newtons and the distance is 40 centimeters. You got to convert 40 centimeters to meters, right? So it is 0.4, 40 centimeters. So it is 0.4 meters. Do you understand?
Oh, yeah.
Divide by 100. So that is first part, then only you get Newton meters. And the other forces are negative because they are counterclockwise. So negative of 15 times zero point 0.5 and negative of 60 times 20, right? Sorry, that is, I wrote it in the other way. Anyway, zero point 0.6 times 20. So can you figure out how
15.
much is this?
Um, wait, is it 20 times
Point,
um
point,
1.1?
no, oh, I'm sorry. I'm sorry. Let me redo
You
it.
add them.
Sorry for that. Oh,
That's
yeah,
all right.
yeah.
Just
Wait,
checking.
wait, 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 wait. I wrote 60 also wrong. So 20 newtons is the force and about point P, which is 6 plus 60 plus 50 is 1.1. So it is 1.1 meters. Correct.
Yeah.
So what do you get? Add all these
Um,
values.
So
So basically,
4,
it is sigma F cross.
4 minus 7.5 minus 22 minus 25.5.
So we say, so it is, they are saying Newton meters, and you write minus 25.5 Newton meters, right? So
Mhm.
this is, and in the bracket, you can say counterclockwise or anti-clockwise, right?
Yeah.
Perfect. So that is how you're going to answer the very first question. Let's take up the next question.
Wait, so in that case, it was anti-clockwise.
Yeah, so because find total clockwise moment, you write negative whatever you got, correct?
Right.
Whatever you got, Newton meters. In brackets, you can write counterclockwise.
Oh, I think I really misunderstood. So this whole clockwise mode, like because it was total clockwise, just so if there is an anti-clockwise as well, you have to subtract them. You can't
Yeah, of
just
course.
take the
Net will
clockwise.
be, yeah, the net, if it is negative, it means it is counterclockwise. So assume that you're considering clockwise as positive. Is it okay?
Okay. Yeah. Yeah. Sorry, what was the next question?
Question number 2, let's take that.
Oh, 2. Okay. So yeah, 2.
A plank of wood 6 meter long, so they are given 6 meter long wood, okay, rests on supports at A and B at a distance of 1 meter and 2 meter from the opposite ends of the plank as shown. The mass of the plank is 9 kg. State a suitable mathematical model for the plank. So what mathematical model are you going to use for the plank?
Yeah, when I read this question, I actually didn't understand it. I thought they meant the diagram.
No, it is
Oh.
rod. So we will assume that the plank is a rigid body, right? So it is a rigid body. I mean,
Oh, they mean like, oh, right. You know how like a person would be a particle like that?
yeah, it's a rod. So you will assume this as a rod, which basically means a uniform with, okay, so rigid body, we are assuming this to be a rod, right? Rod basically means it has a length with negligible
Mass.
width,
Mass.
mass. No, mass
Oh,
is
width.
mass is there, but it is focused at, so you say uniform.
Oh, focused at the center.
We say uniform. In that case, we say mass is concentrated at the center. We say geometric center.
Oh, okay.
Correct? So that is what you have to write this as a mathematical model. And rod is a rigid body, right? So it's a rigid body. When I say rigid body, it means it will not buckle, it will not get deformed with all the
right.
forces acting on it, correct?
Yeah.
So it has a length only which we are considering, which they have given us as a length of 6 meters, right? So 6 meter length. So you will not be considering width of this, like a straight rod, right? So only one dimension. So it's a one-dimensional rigid body, you can say. Is it okay?
Mhm.
So plank will be taken as a one-dimensional rigid body. Perfect. Now let's solve. Using this model, calculate the forces exerted on the plank by supports at A and B. So basically, we want to find the reaction at A and B, right? So
do you want me to zoom out? I can
we will work on
get
it.
space on the side.
Oh, that's good. That's good.
Yeah, it's the first time. I don't know how.
That's good. That's good. That's better, right? So let me just erase what I just drawn there. So we'll redo that drawing. Perfect. So basically what we're trying to find is reaction at A and reaction at B, right? Let me draw it here. That'll be better. So we have a rod here, which is supported at 2 points, A and B, 1 meter and 2 meter. drawing, of course, is not to the scale. So 1 meter and 2 meters. The rod length is 6 meters, so it's 3 meter in between. Perfect. What we need to find is the reaction at A and B. So that reaction is what we need to find. So RA and RB. These are the supports at A and B. Is that okay?
Yeah.
And we are also given that the mass of the plank is 9 kg. So it will act right at the center, right? So right at the center, 9g. So weight will be, we have to multiply by gravity, 9.8, right, as given to us.
Yeah.
Perfect. So since the length is 6 meters, it will be from here 3 meters, right? So 2, 2, and 1. Do you understand this part, right?
Mhm.
Okay. So now to find the reaction, what we can do is simple as that. We know what is RA. Their sum is, we resolve them vertically. So vertically, all the forces they are in equilibrium, right? So it is 9g. Is that okay?
Yeah.
So the reactions are same as the downward force, which is 9g newtons. So that is first equation. To find individual values, we can take moment about A or about B, any point you want, right? So let's take about A. So if I'm taking moments about A, in that case, the mass is causing clockwise, correct?
Yeah.
And this clockwise, we'll say clockwise is positive for us, right? We'll assume that. Okay. So this clockwise is because of 9g, and the distance is 2 units. Is that okay?
Mm-hmm.
Because from the end, it is only 3 units, and 1 unit is already there. So 1 plus 2. That should be equal to the counterclockwise moment caused by the RB, right? That tension. So this is going to cause counterclockwise. So which is RB. And how far is RB from A?
3.
3 units. Perfect. So we get RB as equal to 9 times 9.8, I'm now writing, times 2 divided by 3. Can you use calculator and find the value, please?
Yeah. So 9 times 9.8 times 2.
So 2/3 of that, basically. And 1/3 will
58.
be,
Yeah, 58.8.
and therefore RA will be equal to 9 times 9.8, right? Minus 58.8. Is it okay?
So RA is 9 times 9.8. Oh, wait, sorry. Minus 58. 29.4.
So what you also notice here, it is very important to check, Emmy, that is at RA, it is 1/3. You see, RA is 1/3 of, RA is 1/3 of weight. And RB is 2/3 of weight. Do you see that?
Of the weight.
Yeah, because this was 1 unit away. Do you see? If you see from the center,
Yeah.
2 positions, correct? So, so they, when you see 2/3 here of 9
Yeah.
times 9.8 is RB, right? More than that at RA, right? Anyway, it's important to see that, and then you could correlate these things also. Anyway, we got our answer. Units are in newtons, of course, and so we have this as 29.4 newtons, and this is 58.8 newtons. We have 3 significant figures, correct?
Yeah.
So that is how it can be done.
All right.
Let's take the next question. This size is okay, I can read. So question number 3 is PQ is a light bar of length 5 meters Particles of mass 3 and 5 kg are placed at P and Q, that means two endpoints respectively. The loaded bar is then suspended by a light string attached to it at the point R, where PR is x meters. Given that the bar hangs horizontally in equilibrium, find the tension in the string and the value of x. Correct? Okay. So let's draw the diagram first. So light bar, so let's say this is our light bar, which is 5 meters in length. And this PQ. Particles of mass 3 and 5 are placed here. So we'll just space 3. And particles of mass 3 and 5 kg. 5. So we'll write G for newtons at P and Q respectively. The loaded bar is then suspended by a light spring attached to it at a point R, where PR is x. So PR is x. So this is the string at R, and this distance is given to us as x. Is it okay?
Mm-hmm.
You need to find the tension in this string. So let's say, so R, let's call this TS tension. Is it okay? Now, how will you solve it? Very simple. First step first. Vertically, we can say T is equal to sum of 3 and 5.
8G.
Which is 8, sorry, GG, 8G. So that is the value of tension. It is upward force, which will be so many newtons, right? So it is equal to, calculate 8 into 9.8.
78.4.
So that's first part. And now we need to find the value of x. Now, since it is in equilibrium, we can now take the moments about R, correct? So we're taking moments about R. So this 3 will cause a counterclockwise moment. So it should be equal to the clockwise moment, right? So we say the two moments should be equal. So 3G times the distance, which is x, should be equal to 5G times the distance, which is 5 minus
5
x.
minus x.
Okay. So we can now solve this equation. We can cancel G and G. So we get 3x equals to 25 minus 5x. Or we'll bring here 3x plus 5x equals to 25. 8x equals to 25, x equals to 25 over 8, right? So you can calculate how much do you get?
3.125.
So 13, is it okay?
Mm-hmm.
Meters. So we have both the answers. So tension is equal to 78.4 newtons. And the value of x is 3.13 meters. Is that clear to you?
Yeah.
Perfect.
So it's all about resolving vertically and then just taking moments about.
Yeah,
I guess R in this case, because that's the only one that's there. But
perfect.
yeah.
So resolve vertically.
So does the so if it's not in equilibrium,
and sigma of moments, which is F cross D equals to 0. Yeah. If it is not in equilibrium, yeah. If it is not in equilibrium,
then you can't assume.
We'll have some other resultant, right? There will be some motion.
Oh, okay.
So when we talk about momentum and other dynamics, they will not be in equilibrium. The system will move. And we'll find velocity, acceleration, momentum, kinetic energy, all those things.
Oh, right. Okay. So if it's straightforward momentum, we can just say like the upwards force can equal the down and the anti-clockwise equals the clockwise.
Yes. Yes.
Okay.
Perfect. So next question, please. Which is, I think, question number 4 now.
Mm-hmm.
A uniform wooden beam XY of length 7 meters and mass 25 kg rests with 4 meters of its length in contact with the horizontal surface as shown in the figure. Okay, so this figure is given to us. A boy of mass 35 kg stands at Z. So a boy stands here at Z. Okay. A boy of 35 kg stands at Z, where XZ is 3 meters. Okay, so just at the edge. And then walks slowly along the beam towards X and walks in this direction. Find how far the boy can walk before the beam starts to rotate about Z. So this is like tilting position. Do you understand now?
Mm-hmm.
Part B is find the smallest mass that must be placed at Y so that the boy can just walk to X. I mean, all the way through. Okay, so let's try to do this.
Oh, without it tilting.
Yeah, a tilting example. Let's sketch the diagram. So we have this particular.
Oh, this is a different question.
Yeah, and it is supported some way. It is supported, right? So it is supported on a wooden, on a table, for example, right? So that is the scenario. This point given to us is X. This is Y. This point is Z for us. And the whole length is 3 and 4, which is 7 meters. So this is 3 and this is 4. Perfect. So we have a boy who is starting to walk from Z. So let us assume that before tilting, the boy is able to walk a distance of X. Let us say X. Is it okay?
Yeah.
So this is the boy for us. Okay, that's good. So when it tilts, at that time, moments about all other points are 0. So tilting, important thing to understand is reaction at other points is 0.
All right. Okay.
So that's the condition. Now we have a wooden beam whose mass is 25 kg. And since it is 7, so it'll act at 3.5, right? So 3.5 somewhere. Let me just put somewhere here, right? So this is 25 kg, 25 G, right? And this distance is 3.5. Perfect. So that is the weight acting. Now we will take moments about which point do you want to take our moments? Tell me. So let's say,
we don't.
Yeah.
Oh yeah, you said read the question because, yeah, let's read the question again.
So the uniform beam is 7 meters. Mass of the boy is 25 kg, which rests with 4 meters of length on one side. So we have to take moments at Z because tips at Z, right? So we have to take moments at Z itself. Is it okay?
Oh, so wherever the tilting is, you take the moment at that point.
At that point. So,
oh, okay.
Yeah, so because tilting is taking place at Z itself, so we'll take at Z. And 3.4 of 3.5 is obviously on the right side of Z, right? So this will cause a moment which is in this direction, right? So here is the point, so it will cause clockwise. And the boy will cause counterclockwise. So they should be equal. You get the idea?
Right. Yeah.
So clockwise moments should be equals to the moments which are counterclockwise. Clear? So the clockwise moment here is due to the weight, which is 25 G. And the distance is how much? 3.5. This is, we are taking at G. The weight is at 3.5 and this is at 3. So 0.5 away, correct? Point Z is at 3, right? So the distance is 0.5. Is it okay?
Wait, is the point Z at 3?
3.5 minus 3. Z. We are taking at Z, right? Which is 0.5.
Yeah.
And the clockwise is the weight, which is how much of 25 kg? No, 35 kg is boy weight. So it is 35g times x. Is that clear to you?
I think I need to redraw my diagram. There's a lot going on.
Let me draw a bigger one so that things are very clear, right? So
How do you know where like the center of the mass is compared to like?
I'll just show you in a bigger diagram. Is it okay? Have a look.
Yeah.
This is 3, this is 4, and 3.5 will be here, right?
Mhm.
At 3.5, we have the weight, which is 25g. The boy is at a position which is, let's say, x unit away, right? This is from here, this is x, and this is how much? 0.5. Is it okay? This is z.
So is it 3 from X to Z?
Yeah, from x to z. Yeah, I mean
Oh,
this x
I
is
thought
my
that X was.
no,
Oh, okay.
this small. This is lowercase x, which is my distance. Is it okay?
Oh, right. Yeah. Sorry.
Distance. So
Yeah.
yeah, I should not have used x. We could use something else. Anyway, so now you understand, correct? So from here, we can find the value of x, which is 25. G and G cancel, correct? That always happens here. And we have 0.5 in the numerator and 35 in the denominator. Can you just calculate this value? Round it to 3 significant figures,
Okay.
meters.
So we got 0.357. So you would want it to 3SF?
Yeah,
Yeah, 0.357.
meters. So that becomes your answer. So the boy can walk that much. That is how we'll do part A. Part B is, what is the smallest mass that must be placed at Y so that the boy can just walk till X? Is it okay?
Mhm.
Now, okay, so let's redo this. In that case, what happens? Let's do part B here in smaller space. So if the boy is able to walk up to this place, then finally 35 kg will be at X, right?
Yeah.
So the moment, which is counterclockwise moment, will be 35 times 3, right? Because the distance is 3
Right.
from G, right? And that should be equals to 25 times 0.5 plus mass, which is acting here, right? And mass will be 4 units. This is mass M. We'll say mg. So it'll be 4 times mg. Is that clear to you? If I place a mass here to counter the weight of the boy at the other end, what should I redraw? That's clear. No problems. Let's redraw.
Okay.
So we have x, y, and z.
So just a question in the exam.
Yeah.
With your diagram, if they give a lot of parts, do you recommend drawing a new diagram for each part or like do it on the same one? Because it can get a bit confusing.
Yeah,
If it's the same.
you're right. So it makes sense to draw.
Do you have time to like
Yeah.
draw?
So this is 25g, right? So now the boy is here, right? Do you see that 35g?
Yeah. Oh,
And
because he's at the
3
end.
units, and total was 4, but this is like 0.5, right? 4 was from here to there, right? You see that?
Yeah.
And
That
this is 3.5.
Where's the center again?
Center at 3.5, right? Total length
Is that 25G?
yeah, 25g.
Okay.
And now what we are doing is we are placing extra weight here, right? So which is mg, to counteract. So we have the moment because of the boy, which is anti-clockwise, and that is 35 g, and the distance is 3. We are taking moments about z. Is it okay?
Oh, okay.
And here we have.
Wait, so how come you chose to take it about z?
Oh, because that is the tilting point, right? So this point was the actual point.
Oh, okay, yeah.
Now, and the other force is 25 g, which should be multiplied by 0.5, that is the distance between the center, let's say center is C, and Z. Plus the mass mg is 4 units away, 4 meters away. Is that clear to you?
So at a Z, 25 g times 0.5.
So we can now calculate this mass, which is 35 times 3 minus 25 times 0.5 divided by 4, correct?
Mm-hmm.
That is the mass required at the other end, which is y.
Just calculating. Wait. Oh, there's the unknown value. Just got lost for a second.
No problem.
So M is 23.125.
125. So it should be on the higher end. So we'll say 23.2, right? If I make it 1, it will tilt, right? So many kg. You have to be careful about the units, right? So force is newtons, mass, kg, Newton meter is the moment. Is it okay? Are all these steps clear to you, Amy?
Wait, just the last step. So the question saying find the smallest mass that's been placed so the boy can just walk. So why did you round it to 2 again?
You got a value which was 23.12, you said, right?
Yeah.
If I put 23.1, that means it is lesser than required. Then it will tilt, right? Boy will not be able to.
Oh, because 0.25 is also there. Yeah. Okay.
You get the idea. So we have to round higher. With 0.1, it will tilt.
See, because whenever you write things down, you don't ever think about why. You don't think about because this is so real. You need to think about the actual realistic reality of it. Whereas if it's just a different thing, you just write 0.1 and that's it. Oh, okay.
So smallest mass that must be placed at y so that the boy can just walk to x. So if it is less than 23.12, it is going to tilt. So I cannot write 23.1. Is that okay?
Right. Yeah. That's really clear.
So 23.2 is the closest.
Yeah.
Significant figures, right? So the answer is 3 significant figures. Very important to note. Higher we round it in this case. Is it okay? It's like if you have to paint your house, you cannot buy 2.5 cans. You have to buy 3 cans. Correct?
Right.
That is what it is.
Same. Yeah.
Correct. So let's clear this and move on to the next question. Can you please slightly raise, or I can no, the other way. Yeah. Okay, that's fine. A light rod AB, when it says light, that means mass is neglected. A light rod AB of length 10 meters has a mass mkg and has masses mkg and 10 kg attached to the point C and D. Let me draw this first. Then we'll read and work it out.
They're trying to confuse you with words.
Yeah, there are too many things, right? So rod
masses and
so a light rod AB, 10 meters, length 10 meters, okay, 10 meters. So has masses mkg and 10 kg attached to point C and D, where AC dB is 3. Okay, A to C and D to B is 3. Okay, so we have masses here and here, and these points are C and D. and they are 3 units away. Please confirm. A light rod AB of length 10 meters has masses m kg and 10 kg. Okay, this is m kg.
Is it respectively?
Yeah, 10 kg. It is attached at C and D, where AC and DB are both equal to 3 meters. Now it is perfect, correct?
Yeah.
The rod is suspended by a vertical string attached at A and B. Okay, both places. So we have a vertical string attached here and also here. Okay. If the tension in the string at B is twice that in the string A, so T and 2T, right? So we'll write this as, T, tension 2T. Okay. If the tension in the string at B is twice that in the string at A, find the value of M. Now it's clear, right?
Yeah.
So we know this tension, upward force is T and 2T, downward forces M and 10G, right?
Do they equal each other?
Now it's an equilibrium, right? So let's work out first vertical, correct?
So 3T equals 10 plus mg.
T plus 2T is equal to M plus 10G. Is it okay?
Yep.
So 3T is equals to, let me write mg plus 10G. How does it matter? I don't want to divide this side. Okay, that's fine. So we have one relation. The second one we can find using moments, right? So which point should you consider? If the tension in the string at B is twice this, find the value of M. Okay. So let's find moment about some tension point, right? So this point or that point, whichever.
It doesn't matter.
A or
oh,
B?
okay. A.
A, okay. We'll use this one. A. So when you're using A, in that case, because of this, it is moving clockwise. Because of this, moving clockwise. However, because of 2T, it is going counterclockwise, correct? So the counterclockwise, yes.
Are we doing in relation to, like, so from A, where are we like going? Are we doing it to the reactions of C and D?
Yeah, moments at A. We are finding moments at A. And since it is an equilibrium, their sum should be 0. Is it okay? Or we can say clockwise equals to counterclockwise, either way.
Oh, okay.
So let's do clockwise equals to counterclockwise and work it out. So the clockwise is because of mg, which is 3 units away from A. So it is 3 mg, right?
Yeah.
And then we have 10g, which is how many units? So the total length is 10 units. So in between it is 4, correct? So that is 4 plus 3 is 7. So 10,
7.
10.
7 times 10g.
Yeah. And that should be equals to 2t times 10. Is it okay?
Yeah.
So we have one equation. Now what you could do is, since we need to find what m is, we can replace t with in terms of m. Is it okay? So let me rewrite. So we have 3 mg. Let me cancel. Okay, we'll cancel g later. Mg plus 70g equals to 20t, correct? So instead of t, I will write, let me write 3 mg plus 70g equals to 20 times t is mg plus 10g divided by 3, right?
Mm-hmm.
From equation.
Oh, you're substituting. Oh, yeah. Okay.
Substitute for 1. I divided by 3 and wrote it. Is it okay?
Right. Yeah.
Let's simplify this. Let me multiply everything by 3. Get rid of denominator, right? Fraction. So we get 9 mg plus 210g equals to 20 mg plus 200g. Is it okay?
Yeah. Times everything by 3.
No, yeah, we times everything by 3, correct? So the left hand terms got multiplied by 3. Now we want mg. So I'll take mg with positive on this
Plus,
side.
I think,
Something
did
is
you
wrong.
forget? Did you just, no, I think you just forgot a 0 for the 21. 210.
Mhm.
Like 70 times 3.
Or 200. Oh, yeah, that is why. 70 times 3 is 210. Correct. I was thinking
Yeah.
why it is becoming negative. Perfect. So we have 210g minus 200g
Yeah.
equals to 20 mg minus 9 mg. Is that clear to you now?
Yeah.
So 20 minus 9 is 11 mg. And this is 10 g. Is it okay? So from here, GG cancel. And what we get here is M equals to 10 over 11. Is it okay?
Oh. Mm-hmm. So G and G cancel. So M equals 10 over 11
kg.
kg. So is that the amount of mass that you can put at?
Yeah.
Oh no, this is a different question.
But at C, this is the
I'm
amount of
still
mass
really engrossed in that walking on the plank one. That every question's merging into that. Oh, okay. But yeah, still. Yeah, that one makes sense.
Is
So,
that okay? Very
yeah.
colorful. Looks beautiful.
I like it. Very pretty.
So we'll keep it as fractions, okay? Because they
Okay.
say fractions or 3. Fractions better. 10 over 11 kg.
Yeah.
Perfect. So we got this. Let's do the next one, which is probably the last one now. 6. A
6.
non-uniform rod AB of length 2A is suspended by 3 vertical strings attached to A, C, and B, where C is the midpoint. So A, C, and B of AB. The tension in these 3 strings are in the ratio of 3 to 1, respectively. Find the distance from A to the center of the mass of the rod. Okay, non-uniform. Do you see this? Non-uniform means
You can't put
the
in the
mass is
center.
not in the center, right? Length is 2A. So let me just sketch this first. Very important to get the right diagram.
Yeah, definitely.
Length
Because you're
is
basing all your calculations on it.
and we are saying this is A to B. A to B. And C is the midpoint. There are 3 strings at ACB. So let's draw the strings now. Perfect. So the tension in these 3 strings is in the ratio of 3 to 1. So let me write this as 3T, 2T, and T. This is tension. Find the distance of A from the center of the mass. So we don't know where the center is. Let's put it X because we have to find distance from A. So let's say from A, center of the mass is somewhere here. Right? We call this as mg and let this distance be X. Is that clear to you?
Yeah.
Easy. So now, how will you do this? Amy, can you help me? Upward forces are these tensions, right?
Yeah.
Vertical resolution.
Has to equal mg.
So 3T plus 2T plus T equals to mg. Is it okay? So 3 to 5 and 1, 6T. 6T equals to mg. So T is equals to 1/6 of mg.
Yeah.
Perfect. So we can, substitute for T. Now we have to take moments, correct? Second step is take moments. And which
So
point will you choose for moments? A? We can choose A.
at the point of tilting.
There's
Oh
no.
wait, no, there's no tilting here. Oh, okay. Okay. I really wanted to cancel the other C and B.
Yeah.
Okay.
That's so true.
Can't just randomly make tilting appear. Okay.
We'll
Yes,
take
then
about
take
A,
it
right?
A. Mhm.
Let's stick with A, right? So this mg will cause a clockwise movement, and those other tensions will cause counterclockwise.
Anti-clockwise.
So the other ones are so the clockwise is mg into x, right? So we get one equation which is mg into x, which is equal to the counterclockwise moments. Let me use another thing for that. Okay. So these are causing counterclockwise moments.
Wait, was C the midpoint? So 2a minus x.
So this is A, right? So 2t into A.
Oh yeah. And then that part is
Wait. So t times
A
2A.
minus.
So we get 4A, right? So mgx, we have mgx equals to 2t, 2t is 4t, right? 4ta, right? So we can substitute the value of t. So we got 4a and t is 1/6 of mg. Correct? Find the distance from center to the rod. We have to find only x. mg gets cancelled. Do you see that?
Yeah.
So the value of x is clear. 4/6a, which is 2/3 in meters. So they have not given any units. 2a suspended, 3 vertical suspended, and the ratio of this. Okay, just
Wait, where did the other
pardon?
4TA?
So I substituted for t. I substituted.
Oh.
You see that? T is
Yeah.
1/6 of mg, right? So
Right.
T is 1/6 of mg. That's what I wrote.
That's where I got a little bit, whoa, what happened kind of thing.
Yes.
Okay. So
mg got cancelled. And we got our answer. We could have substituted mg equals to 60. I could have substituted mg as 60, right? That was easier. Well,
oh yeah,
t would have cancelled.
that's true.
That. Yeah. So we could go the other way, right? We could say mg equals to 60, and then tt will cancel to get our answer. We have to find x, right?
Oh yeah.
Okay.
We kind of went the long way.
Yeah.
Slightly.
X is 2/3 of A. They're not given any units for A. So a uniform, this vertically stretched by this, where this is tension. Okay. So in the units of A. Assume.
Or is that what you write?
In meters. Well, it could be any unit, because then you have to convert to meters to get Newton meters. Okay, otherwise. But anyway, so units of A, right? It's the ratio. It's in terms of A.
Right. Yeah.
So the ratio, it is basically 2/3 of A, 2/3 of the whole length, basically. A could be any unit, right?
Yeah.
It's a ratio. So it could be any unit. So 2/3 of this. Perfect. So that is how, so slightly less, the diagram is correct for that matter. Perfect. So did you understand all these?
Yeah, that was really, really helpful. I thought, yeah, because the thing is that over the weeks it's been going by, I thought I've been like making it really big and scary in my head about mechanics. But then the more we've gone through it over the week, and then like finally doing exam questions, it wasn't actually that bad, even though the marks are like crazy high, like 8 and 7 things. I think as long as you get the diagram right, and just you have to reread the paragraph like 5 billion times, but like after like really picking out every sentence and where the weights are and if the person's moving, if they're not, kind of thing, then you'll be okay, and you just work individually and it'll be fine. Because all the forces anyway are perpendicular. They're not like those questions we worked on where they were like sine and you had to find the perpendicular angle to the force. So yeah, apart from that, it's quite straightforward, I think. But yeah, I can see myself finding a question where it'll be a little bit tricky. But yeah, these ones were okay. So yeah, I think I'm getting it.
Perfect. So we can end the class here.
All right.
Yeah. So Amy, you learned all this concept. Is there any doubt in your mind about solving such questions?
No, none.
So we can end our class here. I hope many other students will get a lot of benefit in understanding how these questions should be solved.
Definitely. Thank you
Okay,
so
then.
much, sir, for your
Thanks a
help.
lot. My pleasure.